హాయ్ ఫ్రెండ్స్, మనం ఇప్పుడు ఈ పిక్చర్ని 2Dలో అసెంబ్లింగ్ ఎలా చేయాలనేది చూద్దాం. లాస్ట్ క్లాస్లో మనం డిస్కస్ చేసాం, బట్ అగైన్ వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ దిస్. సో లుక్ ఎట్ దిస్ ఈజ్ ఏ షాఫ్ట్ అండ్ దిస్ ఈజ్ కట్టర్. ఓకే, హియర్ ఈజ్ గ్యాప్ ఇస్ దేర్. ఈ గ్యాప్లో మనం వచ్చేసరికి ఏంటంటే ఈ స్లీవ్ ఏదైతే ఉందో ఈ గ్యాప్స్లో మనం ఫిక్స్ చేస్తాం అన్నమాట, ఈ రెండు స్లీవ్స్. ఓకే, so this is three-dimensional diagram. So total length, how much you can just here look at this. Total here to here is 8D, and here to here is 0.4D, and here to here, that means this distance is called 0.4D and 8D. సో టోటల్ డిస్టెన్స్ క్యాలిక్యులేట్ చేసేసి మనం ఇక్కడి నుంచి టోటల్గా ఇక్కడికి ఎంత డిస్టెన్స్ ఉంటుందనేది మనం చూసుకోవాలన్నమాట ఫస్ట్. ఓకే, సో first I am going to draw axis line. So this is axis line. We are going to see here, I can take here to here distance. So here to here distance is called the total distance. Okay, total distance is there. So first point is here to here distance is coming to point here. Now height, for example, diameter is given here. Diameter is 20 is given. You take first one is coming from here 10 mm, 10 mm, పైన 10 mm, కింద 10 mm తీసుకుంటాం. తీసుకున్న తర్వాత ఇక్కడి నుంచి ఇక్కడికి ఎండ్ అనేది ఫిక్స్ చేసుకుందాం. 10 mm, 10 mm. ఓకే, అండ్ నౌ డ్రా ది ఇమాజినరీ లైన్. ఓకే, ఈ విధంగా ఇమాజినరీ లైన్ డ్రా చేసుకున్న తర్వాత మనం నెక్స్ట్ స్టెప్ వచ్చేసరికి ఏంటంటే ఇక్కడి నుంచి మనకి 0.4D, దిస్ డిస్టెన్స్ ఇస్ 0.4D. ఓకే, సో దెన్ హియర్ టు హియర్ ఈజ్ 0.4D. ఐ am going to fix like this 0.4D, and again here is 25.D. So this is the height. Okay, this height can show this. See here, this height is called you can take 2.5 into D. So that means 2.5 into 20. So we are going to increase this height, right? And then here similarly we are going to same process in here also. 0.4D and 2.5 into D. I'm going to draw imaginary line like this, and this is the axis we know very well. So we are going to fix this one. ఇక్కడి నుంచి ఇక్కడికి హైట్ ఎంత తీసుకున్నారో అదే హైట్ ఇక్కడి నుంచి ఇక్కడికి తీసుకోవాలి. అండ్ సిమిలర్లీ ఇక్కడ కూడా మనం సేమ్ ఇక్కడ ఎంత హైట్ తీసుకున్నామో అదే హైట్ ఇక్కడ తీసేసుకొని we can draw thicker line. Okay, we draw here thicker line, and then now here we are going to see here to here distance is 1.3D, and now here we are going to fix the sleeve. Okay, that sleeve height is coming from 1.3 into D. Okay, that sleeve also having 1.4 into 3, 1.3D. This is sleeve. Okay, similarly we are going to fix here to here 1.3D. Okay, and now we are going to see here how much gap. It is 1.53. This is also now. Then here 1.1 d distance, and here also 0.1 d distance. Why? Because here we are going to fix sleeve. Okay, and then now here 1.3d and 1.3d. Okay, so here I am going to fix sleeve distance like this. To go into line, mostly it will come like this. This is important part. Okay, we just careful about this. This is the gap. Okay, and similarly we are going to see here also like this, at this one also like this. Like this. Okay, so now I'm going to draw a thicker line. ఈ విధంగా మనం థిక్గా లైన్ గీసుకోవచ్చు. This is shaft end. Here also we are going to draw a thicker line, and this is hidden lines. ఓకే, ఎందుకంటే ఇది ఇన్సైడ్లో ఉంటుంది కాబట్టి మనం వీటిని హిడెన్ లైన్స్ కింద చూపించుకోవాలి. ఈ విధంగా చూడండి, దిస్ ఈజ్ ఎంటైర్ షాఫ్ట్ and this is cutter. Okay, now we are going to see here, this is dark line. Now I'm going to hatching this part. This is sectional cut. See this is sectional cut, and now I am going to give the measurements. That means here look at this, ఈ షాఫ్ట్ మనం ఈ కట్టర్ డ్రా చేసాం ఇక్కడ. ఓకే, 2D లో. And then now here we see this part, this 20 diameter. So then here we are going to see 20, above 10 and below 10. Okay. So, okay, right. So this is having this. So like, so this is called D20, and then now here too, your distance is called 1.3D. This is 1.3D you can take, and now here to here distance you can take, this is called here 2.5D. Okay, now I am going to see here some of the line 0.1 into D. This is the gap, and now here also it will come 0.1 into D gap, here and here also. Okay, so this is 0.4D, this is 1.3D, and now here is distance is called 0.1D, and similarly here also the distance called 0.1D, and here to here distance is called 1.3d. Now this distance is called 0.40, right? Okay, so this is the setup, and now we are going to fix this sleeve into here, these two parts. Okay, so look at this, how to fix this one. And take this distance is 4 into d. Calculate 4 into d, that is coming from 20 diameter. So 4 into d is 80. So you can take here to here distance is 40 and here to here distance is 40. And similarly, this point you can take center point, and here to here 40 and here to here 40. And then now here to 40. Okay, and now here also you can draw imaginary lines, and then take this projection below like this. And this is also project upward. This one is upward projection, and this one is downward projection here to here. Then close it. So this is sleeve. Look at this, this is sleeve. Okay, and then now here inside it between, you have to take center, exact center point. You can take this one and give the distance here also 0.1d, 0.1d here and here. Now this is also not endless, like this you can fix it. These all are cross-sectional cutting. Okay, so this cross-sectional cutting we show here like this. Okay, see here, this is hidden lines. Okay, and then now we are going to see here to here distance is called 0.1d, and then now you can see here to here distance also 0.1d. The total distance here come to this point here to here. The distance is called here 0.8d. Sorry, not 8 into d. See here 8 into d. 8 into d. Okay, so this is the diagram. You can draw like this. And this we are seeing on top view. This position we are going to see on top view. Now how to draw the top view you can see. Take dropper and draw the all projection lines. Don't miss it. Okay. This is maximum strength. So this. You just project all the lines to this one here, to this maximum line. You can take like this. Okay, right, and then here this gap is there, so you can project like this gap also. And then come to here. Come to this. And this maximum distance you can project using a projection line. You can just project this thing. Now here the maximum point you can take, you can view the projection lines like this. Come to here, and this is a point. Here you can draw projection line. Here also having point, so projection line you can draw like this. So these all are projection lines. Okay, then we are going to see first one is shaft. Before going there, first we are going to fix here cutter. This is upper face, this face. Okay, and now I am going to draw this one. This is half cross sectional cut. So then I'm showing like this. This is end, and now showing like this. So this is point here. Now what is I highlighted, you just follow that. Thicker lines, you can observe only thicker lines. ఏవైతే లైన్స్ థిక్గా డ్రా చేస్తున్నానో వాటిని అబ్జర్వ్ చేయండి. And then now here is coming from the gap between in here. This is the thing, and now here is we are going to see top fixing on sleeve. Cross sectional point of view, we are going to see like this. See here, we are going to hatching like this. Okay, and then now here is axis line. Center axis, we are going to draw center axis. Okay, and then now see here, this is the dotted lines. So this is shaft. Okay, and then here is we are going to see this is end, and this is end of the shaft. So here we are going to fix. Okay, this one. Okay, see this. This is the part, and this is the part. Okay, on top view position we see here also have sleeve. We are going to fix sleeve like this. This is 1.3D distance. Here to here distance is 1.3D. You can take to draw the diagram. Okay, so this is the procedure to draw the cutter, sleeve and cutter. This is the exam point of view. We can draw like this, not like this. Okay, they given the dimension in here. This diameter distance is given 20. So then you can take D is equal to 20. You calculate all those things. For example, you want to know this length means you can calculate 0.4 into D, 0.4 into 20. You will get this distance. At the same time, you want to know this 1.3 into D. So you can calculate similarly 1.3 into 20. Like that, you will get this distance. So you calculate. So total distance here to here distance is 8D, 8 into 20. That is called approximately 160 mm. So you can take all calculations, okay, and draw carefully. But this is a they are given only the question point of view. They given only diameter D is equal to 20 mm to draw the sleeve, cutter joint with the sleeve. Then you know very well about this diagram. Okay, ఈ డయాగ్రామ్ షేప్ అనేది మనకు తెలుసుంటే మనం ఏంటంటే ఈజీగా గీసుకోవచ్చు. దట్స్ వై ద పాయింట్ హియర్ ఈ డిస్టెన్సెస్ అన్నీ కూడా మనకి గుర్తుండాలి. Okay, that's why here we can see here three-dimensional diagram, easily understand. So this part all are coming from cutter, the shaft cutter, and this is also one type of cutter. In the shaft, okay, we are going to fix one cutter and లాక్ విత్ హెల్ప్ ఆఫ్ స్లీవ్స్. ఈ స్లీవ్స్ తోటి మనం దాన్ని లాక్ చేస్తాం బయటికి రాకుండా. ఓకే, ఆ విధంగా మనం ఇది యూస్ చేస్తాం అనమాట. దీన్ని మనం 2 డైమెన్షన్లో కనుక డ్రా చేసి చూసుకున్నట్లయితే ఈ విధంగా కనిపిస్తుంది. ఓకే, రైట్. ఓకే, నెక్స్ట్ వీఆర్ గోయింగ్ టు సమ్ అనదర్ థింగ్, షాఫ్ట్ కపుల్. ఓకే, ఈ షాఫ్ట్ కపుల్స్ నెక్స్ట్ క్లాస్ వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ దిస్ థింగ్స్. ఓకే, థ్యాంక్ యూ.